The Helix agent is a reflexive financial AI agent designed to answer complex financial questions without the hallucinations or inefficiencies of a standard chatbot. It is built on a modular stack using llama.cpp, LangGraph, VLLM semantic router, and the Model Context Protocol. On the right, I have opened multiple terminal where I started the relevant services so we don't wait during the demo. First, our llama.cpp server with a QN local model. Then the VLLM semantic router providing a single endpoint for chat completion and routing, telemetry, and a web dashboard. Next, our MCP server based on FastMCP, providing access to financial tools built on Yahoo Finance API, and some distraction tools to test our ToolRAG retrieval logic. Finally, we have a simple Streamlit app that interacts with the agent command line interface. Let's now have a look at the various web services running on my HPZ-GX Nanobox, a compact personal AI supercomputer where my agentic development is taking place. The first web interface is the Streamlit app. It provides access to a synthetic data generation tool that builds financial queries used to test our model routing logic, the tool selection, and the reflexive function of our agent. We have already generated a full data set of 50 records for this demo. This includes financial domain requests of various types, including requests on stock fundamentals, historical market data, financial statements, or company news, but also different types of hazard queries that try to trick our agent. We can select one of these records to have a look at the details in the interface. In this case, we are asking the agent to provide the PE ratio for Nike, which should be a basic request to a financial API. Once the record is selected, we simply run the agent and let the processing go through. We move on now to the VLLM semantic router dashboard. It provides full visibility to our model routing configuration, starting with the two models we are using in our agentic orchestration. The QN3 model is used locally for the financial agent core execution logic, and the Gemini 2.5 Pro model for synthetic data generation and agent evaluation. Next, we look at the configuration for the routing logic. The VLLM semantic router implements a signal decision architecture, which reimagines semantic routing by separating signal extraction from decision logic to capture the full context of a user's intent. It operates by extracting three complementary inputs: keyword signals for interpretable regex pattern matching, embedding signals which use neural models to understand semantic nuance, and domain signals that classify subject matter using MMLU-trained models. Finally, a flexible decision engine combines these signals using weighted logic to route the query to the specific model. The VLLM semantic router dashboard also provides a graphical interface that shows the components involved in the end-to-end routing decision based on a user query. There is also a router replay function which allows to view and analyze routing decision records for debugging and analysis. We did not enable this in the demo, but it's time now to see if our agent has completed its task. We see that the query has completed, with the agent final response, and an assessment provided by our LLM-as-a-Judge. A pretty good result, albeit on a simple query for this request. The full reasoning of the judge model is provided back to the user for review. Next, we can check the detailed performance of our agent run. Starting with the model selection, where the QN model was accurately selected for the financial task at hand. On the tool selection, we can see the results of the tool retrieval function, the similarity score, and which tool was ultimately selected versus which tool was expected. This ensures we select only relevant tools for each query, keeping the LLM focused and efficient. And finally, we can see the results of internal reflective loop and evaluation performed by the financial agent. For full details of the agent run, typically used in troubleshooting issues during agent development, we have access to the raw trace, which records every single step from the query received. This includes the tool selection, tool call, full structured output of the tool execution results via our MCP server, but also the details of the reflexive assessment explaining the internal evaluation score from our agent, and the external judge assessment. Finally, we use MLflow in the Helix Financial Agent for experiment tracking and end-to-end observability. Everything lives under one experiment, Helix Financial Agent, which tracks every agent run and every benchmark run. This automatic tracing is achieved via MLflow's LangChain autolog. That gives us traces of every LLM call, tool execution, and graph step without extra instrumentation. With this approach, we are also able to capture and visualize in the UI our custom assessments on each trace, whether tool selection was correct, whether model selection was correct, the judge score from our LLM-as-a-Judge, and latency metrics. So we can also easily compare evaluation results across runs. In addition, We also get access here to the full trace of the external evaluation, including the original query, tool calls, tool outputs, agent response, and the results of all assessments performed by the LLM-as-Judge, as well as its reasoning. To find out more, feel free to refer to the code repository for the Helix Financial Agent, which includes a detailed documentation and quick start to set the agent and all required services locally.